Welcome. Today's webinar is titled Rapidly Developing Data Pipelines with DLT Hub and Dagster, and it'll be a good one. Table of contents. First, we'll do introductions. Me, Alex, Alena, and Aashish. We'll talk about what is DLT Hub, how you would use it. We'll talk about the inception of the Dagster DLT integration. And then Aashish will go into a demo of programming with DLT and how you would use it with Dagster. And then we'll briefly talk about what's next for Dagster and DLT and the integration. My name's Colton Patton. I'm a developer advocate here at Dagster Labs. I have a background in data engineering and software engineering, and I'm joined here from Dagster by Alex.
Hi, I'm Alex Noonan. I'm another DevRel here at Dagster, and my background is on my Twitter. My profile is like the People's Data Engineer, and what that means is most of my experience has been around delivering the newest and best tech that is often overlooked in SMBs and bringing it to them.
Nice. And as I said, we're joined by some folks from DLT. Why don't you go ahead and introduce yourselves?
Hi guys, my name is Alena Astrakhantseva. Don't try to repeat my last name. It's impossible. I'm a data engineer and a DLT Hub already more than 2 years. Also, I started my career as a scientist and continued as a machine learning engineer in computer vision. And then I pivoted my career into data engineering.
Pretty similar story here. Hi, I'm Aashish Nair. I'm a data engineer at DLT Hub, and I have a background in data science, but I've also somehow pivoted over to data engineering.
Great, thank you. And as a reminder to everybody, if you have any questions, feel free to use the Q&A in Zoom. And this will be recorded and we'll upload it to our YouTube channel shortly after this.
Yeah, okay. Let me briefly introduce DLT. As you probably know, DLT, it's a data load tool. It's an open source Python library for data ingestion or for ELT. ELT means extract, load, and transform. That's what you usually do with your data. And it helps you load your data automatically. So it automates schema creation, normalization, and data loading. So that's how the pipeline usually look like. You pick the source, you extract your data. So DLT extracts data for you, normalizes, load it to the destination you choose. What the benefits of DLT? First, it's Pythonic, so you can easily install it with a pip install, and easy to use because it has declarative interface, but it's also very customizable because it's Pythonic. So you don't have to learn any frameworks or other languages. You just use Python and quickly switch between destinations, as on this GIF. The best benefits of DLT are, first, you can run DLT anywhere where Python runs, for example, with Dagster. It's also open source. Please give us a star. Not please, yeah, just give us a star if you like it. If you don't like it, let us know. We have extensive documentation. We keep working on it. And also we have community and trying to support all our 4,000 users in our Slack. Join our Slack as well. It's also low cost because it's open source. You can run it anywhere. You can choose any stack. You can, control it as you want. And also it's LLM compatible because it has declarative interface. It's for LLMs, it's easy to create code for you. For example, you can vibe code your pipelines. And small spoiler, in a few days, we release new products. It's called DLT Hub. So it will be a hub where you can find more than 1,000 AI-friendly scaffoldings and instructions how to generate DLT pipeline using Cursor and LLMs overall.
Nice, that's exciting. Cool. So I wanted to talk briefly about the inception of the DLT Dagster integration. So back in, I think it was November of 2023, Pedram created this blog post called Stop Reinventing Orchestration, Embedded ELT in the Orchestrator. And at this point, we had just launched the Sling integration for Dagster. And the thought was Dagster works really well when you pair it with purpose-built tools for replication and ingestion. And the TLDR of that blog post is you shouldn't roll your own ingestion framework or your replication framework. You should use the tools that you love, and you should be able to compose these purpose-built tools from your orchestrator. And then Dagster could handle the things like extracting assets or metadata and forming the lineage of these tools within the Dagster UI. So you get the best of both worlds. You get purpose-built tools for ingestion replication, and then Dagster can handle the things that it's really good at, which is orchestration. So we created a GitHub discussion here. And this is actually October of 2023. And we asked, are there any particular integrations that you would like us to focus on next? And the top voted one was actually DLT by dduong1603. We see him all the time in the community. He's super active. But yeah, so we were like, okay, there's a lot of excitement for DLT. Let's look at building an integration with them. And then a couple of months after that, and it was April 2024 at that point, we launched the first version of our official DLT integration with Dagster. And that was installable under the Dagster embedded ELT package. We since refactored it to be pip installed Dagster DLT as we separated Sling and DLT, so you didn't have as many dependencies in your package. But by April 2024, that's when the DLT integration was available. And here's an example of how you would use it. So you can use DLT as you would typically. So there's some terminology overload to be aware of. In DLT, you have sources and resources. In Dagster, you have resources, but it's different. So on the left, you can see we're defining a DLT source called GitHub Reactions. And this is just calling out to the GitHub API to ingest data. And it automatically handles storing that in different destinations for you. On the right, you can see how we're using that DLT integration from Dagster. So you see we have a DLT assets decorator, and you can just provide that source. So we're saying GitHub Reactions, and then you give it the DLT pipeline. You say, this is the GitHub issues pipeline, and I want to load it into Snowflake. And DLT magically will automatically handle like authentication to the GitHub API and schema management and loading that data into Snowflake. It's really impressive. And then Dagster will automatically extract those DLT resources and represent the metadata as assets in the Dagster UI. So this is an example of how you would use the DLT integration from Dagster. Aashish will actually go into a more in-depth example here shortly in the demo. But I also want to just show like how the excitement is growing for this Dagster DLT integration. You can see it's curving upward. We've seen continuous growth of this integration with 104,000 downloads last month, which is super duper exciting. We also use DLT extensively at Dagster for our internal pipelines. So we were able to dog food the integration ourselves and continue to refine it and improve it. Some examples of that, we use BuildKite for our CI of the Dagster mono repo, and we ingest information about those CI pipelines using DLT. So you can see we have a DLT source here using the REST API source. And Aashish, again, will go into details of this coming up. But you can just provide a schema for an API, and it will automatically handle the ingestion for you. So we're doing that for this BuildKite API, and it automatically knows to do pagination, querying multiple APIs and joining them and writing it all into one destination. So that's one way we're using it. If I go to the next slide, here's that same BuildKite example, and I'm just taking that DLT pipeline and wrapping it in some DLT assets. And you can see on the right, we get to represent those in Dagster. You don't really have to look at the code too much. I just wanted to show the assets. And then here's another example for Dagster University, which you may or may not be familiar with. We use a tool called Thinkific, and we also do analysis on our courses. So we want to see the course reviews, the enrollments, the users, things like that. And we use DLT to ingest that data. And this was actually my first pipeline I wrote with DLT. So you can see we have a resource. This one doesn't use the REST API. I think it was actually written before that existed. But I have some resources and transformers calling out to the Thinkific API and then writing that to Snowflake too for further analysis. So those are some examples of how we're using DLT internally at Dagster. But the good news is we actually open source our internal data pipelines in Dagster Open Platform. So if you want to see how we're using it, you can go to github.com/dagsterio/Dagster Open Platform. Great. So that was the DLT integration at Dagster. And now Aashish will actually go into some code examples of using DLT and the integration itself.
Thank you, Colton. So yeah, let me just get started. But before I get into any actual code itself, I just want to give a quick overview in terms of what you'll be seeing, and that we can split in three parts. So first, yeah, most of you are probably new to DLT and its basic features. So I'll show you what a basic DLT pipeline looks like. And after that, I'll move on to showing you how to expose that DLT pipeline as a Dagster asset. And then finally, we can go above and beyond by improving it even more by incorporating parallelization. So I'm going to take over.
Sweet, sounds good. I'm excited for the parallelization part because that's a question we get often from the community.
And it's actually a lot simpler than it sounds. You'd think it's like it would take a lot of steps, but as you'll see, it's not that difficult to implement. For this pipeline that we're going to build, it's just going to be a basic pipeline where we collect data from a public API. So this API is called JavaShop, and it's basically an API that's based off a fictitious e-commerce service that is based off of DBT's JavaShop dataset, and it's got basic endpoints such as customers, orders, items, products, and supplies. And now what we want to do for this first stage of demo is just to build a pipeline that collects data from all these different endpoints. Before we get to any DLT code, I want to show you what a typical JSON response from such an API looks like. And as you can see here, it's quite ugly. It's in a nested format. From a developer's perspective, let's say that you want to put something like this in a relational database. You'd want to then figure out the best way to flatten this and the best way to turn the semi-structured data into structured data. And there are also many types of annoying things that come with working with APIs. Like Colton mentioned, there's things like pagination. You would want to deal with like retries. Maybe the schema might change for an API over time. So the good thing with DLT is it provides features that take care of that for you, so you don't have to worry about that. DLT will do the heavy lifting for you. And for REST APIs, the main utility for that is called REST API source, which I'll show you right here. It's just something you import, and the input for this function is basically a config. Colton showed you one example of what that looks like, but I'll go over it once again. But basically, the goal is you want to give your pipeline all the information it needs for a given API. So for example, here we have our base URL. We're just telling it the URL for the API. We're giving it all the basic resource defaults, such as the primary key. And then in resources, we're also specifying the individual endpoints. So here we have our 5 endpoints that I mentioned here. This API doesn't have any authentication like an API key or anything. So we don't need to include that here. But if it did, then that would also be part of the config. So what we do in DLT is we basically just run this function and just store another variable. Before I move on, I just wanted to say this. You're going to hear a lot of different terms that you may have not heard before, a lot of different random attribute names or function names, and I wouldn't necessarily get too focused on memorizing every little thing, as long as you understand the what and the why. The how you can figure out in your own at your own pace. So for this demo, with the interest of not collecting every single record, which would take a long time, we're just going to set a limit to 10 pages for every single resource. Moving on, let's actually talk about the pipeline itself that will be facilitating all of the extraction, the processing, and the loading. So here's how you would instantiate a DLT pipeline. It's very simple. You just specify the pipeline name, the destination, and the dataset name. For the sake of the demo, we're also including a log through this line right here. So we can show you what's going on behind the curtain when we actually run a pipeline. So running a pipeline is very simple. You just say pipeline.run, and then you provide the source. But behind the curtain, there's a lot of good things going on, which would be helpful for you to understand. So we ran the pipeline beforehand, and you can see the logs. And when you run a pipeline, there are basically 3 different stages. First, you have extract, where you actually extract the data. Then you have normalize, where you transform the data as you need to, and then load, where you load it in the given data set destination. So in this case, we are using a DuckDB destination. It's an in-process database. You don't need to provision anything beforehand, so it's pretty good for demos like this. If you look at the logs, you can see that there's a lot of extracts here. So that's the first stage. We're extracting all the data. And if you look down here, you can also see the individual endpoints, and there are numbers next to each endpoint, and they basically represent the number of data items for each endpoint. So this extract will keep going on until everything has been collected up to the limit. And then once we extract everything, then we go to the normalize phase. And this is where DLT will look at the data it's collected, and it will figure out what types of transformations will be needed for a given destination. And then once the normalizing is done, you will simply load it. Once you've run your pipeline, DLT also offers you ways to validate your data, because you want to make sure that everything has been collected and everything has been collected properly. So there are many ways to go about this. So I've just included a link to the docs here. But now I wanted to give one example of what a DLT transformation can look like. So here in this kernel, I've just printed out all the tables that are currently in the DuckDB database, the destination. And you'll notice that although we had 5 endpoints in our source API, we actually have 1, 2, 3, 4, 5, 6 different tables. So 6 tables from 5 endpoints. And the reason for this, I can make clear here. So here's basically what our orders table looks like from the orders endpoint. And you'll notice that it's missing one specific field. So if I'll scroll all the way up to our example, our response, you'll notice that it's missing this items column, which basically had our list of dictionaries, which was causing our nested JSON format. So what DLT has done is it's recognized this nested JSON format, and it's taken out the items field and has it's flattened it out, and it has put it in a separate table altogether. And this table is a child table, which is connected to the parent table here on an ID level. So this is just one example of what DLT can do without you having to manually implement any logic. But there are, of course, many features, but this was just one example we thought would be cool to highlight. So now we have one functioning pipeline. Now I want to show you how you can actually expose this pipeline as a Dagster asset using the DLT and Dagster integration, the DLT assets.
Cool. Before you hop into that, actually, I just want to reiterate how cool that was. That you were able to ingest these 5 different endpoints from an API and write them to a destination table without having to deal with the schema, without having to deal with the joins. And it just all worked out of the box. And if you wanted to change this from writing to DuckDB to Snowflake, all you have to do is change that one string in your pipeline. And so that also improves your local to production developer experience. And I just know in the past 5 years, how many times I've written my own ingestion framework, working with data frames and things like that. And this is the framework that I needed back then when I was working on these things. Just super duper cool. Just wanted to reiterate that.
Cool. Yeah. So let's switch over because, it's not over. I'm going to head over to a project in Visual Studio Code, where I'm actually going to show you how you can get the same pipeline working in Dagster. So this part's just going to be me writing things line for line. Here, I already have our project set up with the interest of saving time. So if you're interested in how to get your project to look like this, the Dagster docs includes all of this, all the commands for this in its quick start and its installations. It's very simple and straightforward. I've also performed all the necessary installations in terms of the packages. So I've got DLT installed. I've got the Dagster DLT integration installed. So I am ready to go. To recap, if you recall, before we actually have our pipeline, we need to create our source. Our source is what has all those REST API features, the things like the pagination, the retries, and so on and so forth. So I want to first create that first here before I get to building a pipeline. So what I'm going to do is right next to assets, I'm going to create another file, and I'm just going to call it Jaffle shop source. And literally, I'm going to switch over to our notebook, and I'm just going to copy and paste what we have done here. So here we have our config, and then afterwards, I am going to create our DLT source. There we go. Now we'll go back to our assets. As you can see, I've already imported DLT. I've imported the asset execution context from Dagster. And I've also imported two things from Dagster DLT, which is DLT assets and Dagster DLT resource. I'll get into what both of those are in a bit. But first, let me import this. Let me import the source from this new script that I created. So from Java shop, I'm going to import DLT source, right? And also, I want to include the limits that we had created before because I don't want it to take everything. That would take far too long. So again, more copying and pasting. I'm just going to take this and I'm going to put it here. Again, we're just adding our limits. So we only collect at most 10 pages. And now we can actually get to creating our asset, which is going to be for our pipeline. So I'm going to create a function called def asset. And this will just be a placeholder for now. So no parameters, no nothing returned. And as you can see from our autocomplete, I'm going to be adding our DLT assets decorator. So this is a bit different from the regular native Dagster assets because these are designed for DLT pipelines. So for our first parameter, we're going to define our source. For a second parameter, it's going to be our pipeline itself. And for this, again, we can just reuse our code from our collab. I'm going to go down here and basically this instantiation, I'm just going to take and I'm just going to put it here. Just slide it over for readability. And then next we want to name this. So I'm just going to call this Jaffle shop. Oops. And then finally, group name is Jaffle shop group. Oh,
Typo.
Oh, that is a typo. Okay. So now we can fill out the rest of this function. So first I want to give the parameters. So first is a context. So this is nothing new if you're familiar with Dagster. Oops, I didn't mean to do that. So this is an internal resource. So context is pretty straightforward. But next is something that I'll need to explain in more depth. And that's this DLT parameter, which is a Dagster DLT resource. Oops, this autocomplete, I swear. Okay, yeah, so basically, in our original code, when we ran our pipeline, we said pipeline.run, but instead of this pipeline now, we'll be using DLT, which is a wrapper for our DLT pipeline. When we want to expose this as an asset, we're going to instead be saying DLT.run, DLT being our Dagster DLT resource, and to this, we're going to feed our context. And it's important to note that this expression is just the generator. So if we want to expose the actual asset to Dagster, then we actually need to give it a special key term, which is yield from, which is a contrast, which is a bit different from the regular yield.
Yeah,
so
the yield from is a little bit of an advanced concept in Python. So the DLT run method is returning a generator. So like a list of materializations for each resource that's running. And then we actually want to return those from this asset function. So we're yielding from that generator. And just for clarity, so like we have a DLT resource that's wrapping the DLT package so that we can run those DLT pipelines and then extract the metadata for you. So that's why you use this custom DLT resource. Cool.
Yeah, thank you for expanding on that. So we've created the asset. So now we need to give all the information to our definitions to make sure that this asset's properly recognized. So I'll switch over to definitions. As you can see, I've already taken care of the imports. I've imported the function for creating our jobs, creating our definitions, which we'll be using right now, including our Dagster DLT resource. There's one more thing I want to import, and that is, let me go back to assets. That's this function right here. I want to import, which we'll be using. So I'll say from defs.assets import asset, right? And oops. So I'll be giving this asset to both our job and our definitions that I'm going to create. So first our job, I'll just call this Jaffle shop job. And selection, I will be providing it with the asset. It's important to note that the argument for this parameter has to be in the form of list. Currently, asset is just one element on its own. So I need to put it in a list on myself. It's just a detail, but it's an important detail. I'll do that same thing here. I'll put this in a list. And then similar for jobs, we only have one job element, so I'll be creating that list myself as well. Next is the resources, which I have to fill out. This is important because let's go back to assets. As it is, if our Dagster looks at this function, it's going to know what context is because that is internal. That's an internal resource, but it's going to look at DLT and it's not going to know what it is. So we need to give this information in our definitions. So what we're going to do is, again, the name of the parameter is DLT. That's why this also has to be DLT. And then I'm going to assign this to Dagster resource. That's about it. As you can probably tell, it's not a lot of code for this integration. Yet to see if it works, so let me run this thing. And I'm going to, oops. Let me go to the virtual environment. Okay, so I'm going to head over to the UI and I'm expecting nothing to go wrong here.
Fingers crossed. Live demos are tricky.
Yeah, this is always, okay, there we go. Nothing wrong so far. So I'm going to go switch over to the assets tab here. That's not what I wanted. There we go. And
Yeah,
I'm
view
going
lineage in the top right.
lineage, and then I'm
Nice.
just going to materialize everything to start a run. And let's just view this run and see what's going on. No issues here either. Okay, great. So as you can see, what we've done here is we've replicated exactly what we did in our Google Colab in our Dagster environment. And as you can see, it's run successfully. If you want to look at the logs similarly like we did before, all you have to do is click here and you can click on std out and you have access to the same logs, which can be very helpful. So I want to spend a bit of time looking at these logs because that's going to be a good transition to the next portion of the demo, which is basically how we're currently processing and collecting and processing our data. So what we're doing now is we have 5 endpoints and we are basically saying only move on to the next stage once we've finished the current stage for every single endpoint. So that means basically if we're in the extract phase, we're only going to move to the normalized phase once we've extracted everything. Similarly, we'll only move to the load stage when we've normalized everything. So think of an endpoint like products, which clearly has already collected all the data, as you can see from the logs. It's not able to move on to the next stage because it's still waiting for all the other endpoints to basically catch up. And that's pretty inefficient when it could just move on by itself to the next stages. So a way to improve on this current already working solution is to incorporate parallelization. So rather than having one pipeline that takes care of everything, we can have a pipeline for customers, one for orders, and so on and so forth. So that will overall that'll overall reduce runtime, but it's also something that can make use of the parallelization feature that Dagster offers. So I'm going to show you just how to do that. And it's actually quite straightforward. Let's think about what this solution would actually mean, because right now we have one asset for one pipeline, right? So for parallelization, the logic is that we would now want one asset per endpoint. And if we want one asset per endpoint, we would also want one pipeline per endpoint. And if we want one pipeline per endpoint, we would want one source per endpoint. So basically, this code is a working solution, but if we can modify it such that we can tweak the sources and the pipelines we feed it so that it only works on one given pipeline, then we can achieve parallelization. So I can show you one example of what that looks like. So I'm going to create a function that basically I'm going to wrap around this whole thing. So I'm just going to call it def create resource asset, oops. And inside, the parameter is just going to be resource name. Okay, and I'm just going to put all of this inside. And what this is basically going to do is, I can just show it. So if I say create resource asset, and I say orders, then what I want is an asset for only the orders endpoint, right? So the goal is, if I create this function, then I can basically apply it for all the different endpoints. And just like that, we have a bunch of assets that can be materialized concurrently. But first, we need to modify a bunch of things. Firstly, our DLT source, if I go back to our config, our DLT source currently covers all our resources, right? Which is a problem because we now only want each pipeline to work on one resource. So let's say that we want a pipeline for just the customers. We now want to get rid of everything outside of customers. Similarly, if we want to run something on orders, we want to get rid of everything but orders, right? And we want a pretty efficient way of doing that. Thankfully, there is a pretty straightforward approach. This DLT source object has a simple function called with resources. Oh, sorry about the autocorrect, that was wrong. So there's a function in DLT called with resources in which you can specify which resources you want, and then everything else is going to automatically get omitted. So I'm just going to say resource name, and then I'm also going to go beyond that by adding, I'm also going to go beyond that by also adding that limit that I mentioned before. So I'm going to say resource limit, and let me get rid of this. Okay, great. So what this means is, this is just one line of code, but a lot's happening here. So I'm basically saying for a given resource, take the DLT source we've already created with all the API functionalities and only keep the relevant resources, and then add the limit of 10 pages. So now that I've added the limit here, all this code is redundant, so I'm just going to get rid of it. And I'm going to move on. So now we have our DLT source that we have unique DLT sources for each endpoint. Now we want to have unique DLT pipelines for each endpoint. And the way to do that is very simple. It's just by changing the pipeline name so that the pipeline name for each resource is unique. And this is important because I won't go into too much detail because it has to do with what DLT does under the hood. But if you run multiple pipelines concurrently with the same name, then there's a possibility of one of them interfering with the other. And we want to avoid that. So we're going to make sure that they have different names. Continuing on, I'm going to also modify the name here so that the name value is different for each asset. And finally, since this is a function that returns a single asset for each resource, I also want to return the asset itself. And that's it. With this, we have a function that turns one asset with all the endpoints into multiple assets, each with one endpoint. We're not done yet though, because if we were to give this to Dagster now, it wouldn't recognize this as our asset because we've hidden our DLT assets decorator inside another function. So we actually want to call this function for each endpoint. And this part's pretty straightforward. First, just for demo's sake, I'm going to hard code this part. So I'm just going to list out all the different endpoints that are here. Thank you, autocorrect. So there we have all our resources. So now what I'm going to do is I'm going to call this function with every single element in this list. So all that's going to look like is I'm going to create something called assets, a variable, and I'm just going to say use list comprehension. I'm going to say create resource asset, resource name, resource for resource in resources. Sorry, this should be resources because it's plural. Right. So this asset variable is now going to contain the list of all the assets that we want to run, to materialize. So now we're done with our assets. We went from having one asset here to having multiple assets here in this variable. So we need to, before we go back to Dagster, we also want to modify our definitions to account for the changes we've made here. That won't be too difficult because now here we imported our asset function from the assets file. Now we just want to, this time, import the assets variable here. Now we just want to have access to this. And keep in mind that this assets variable is now already a list. So when we go here and we feed this as our argument, we don't have to manually add our brackets anymore because assets is already a list. So I'm just going to make that change here. And one final change, because now we're going to use multiprocessing, is I'm going to add another parameter which I originally commented out, which is the executor def. And here is where I can configure the max number of workers that are working concurrently. So since we have 5 endpoints, I choose to have max 5 workers. So that's literally it. So going from sequential to parallel, I think I added maybe 4 or 5 lines of code. So it wasn't really that much of a hassle. Here, I'm going to run this once more, and I hope it works. So there we go. I'm going to go to assets and view lineage, the same thing I did before, and this time I'll materialize all. And let me view. And you should already notice a pretty obvious difference. Now, instead of running everything one at a time, we now have 5 workers with each worker basically running one pipeline individually. So if I were to click on one of these individual assets, you can look at the logs, and you can see that as soon as all the data has been extracted, it doesn't have to wait anymore for all the other endpoints to catch up. It can just go on normalizing, and then it can go on to loading. Yeah, that's basically the gist of it. I understand that you guys probably can't and won't understand all the different variables, the attributes, and the functions, but I hope you can understand like what we were able to do with with such little code, and that this is pretty generalizable. If I wanted to do the exact same thing with like a different API, all I would have to do is I would just need to change this config, and it would work the same. Or if I wanted a different destination, let's say BigQuery or Snowflake, I would just have to change this line here for the DLT pipeline and also provide some credentials, and it would work the same. Yeah, I hope this was enlightening and just showed you how some of the features we discussed previously can be like implemented. So I'm going to hand this over back to Colton, who's going to talk about future steps.
Nice. Thank you so much. That was a great demo. And you, like the commenters are saying, you were very brave to do a live demo like that. Yeah, as to wrap up your demo, which you already said, you showed how to use DLT, just vanilla DLT from a collab notebook. You showed how to use the DLT assets decorator from the DLT integration, then how to take it one step further and create a factory pattern to add concurrency into the mix, which was super impressive. Thank you. Yeah, so what's next? We are actively working with the DLT team to make some integration improvements. I know there are a couple open GitHub issues around concurrency, how they work with partitions, things like that. We're very aware of these issues, and we hope to improve that experience. I also wanted to tease briefly the DLT component. If you've been following what Dagster's been up to, we have launched something called components, which is an optional YAML layer on top of your Dagster pipelines. And with that, we included a DLT component. So you can do essentially what Aashish just showed using the DLT assets decorator, but through YAML. So you can provide your source and pipeline, do translations on it, just like this. If you try it out, definitely let me know and let me know if you have any feedback. We're curious to hear more from the community about that. As for next steps, definitely just try out DLT. I know when I first tried it, I guess it was like a year and a half ago at this point, I was blown away by how easy it made writing ingestion jobs, whether that be like replicating data from a database or querying data from an API, not having to handle the schema management or writing to different destinations just makes it so much easier. And you can essentially just return a data frame or a JSON blob and it'll write it for you. We have some communities to join, the Dagster Slack, the DLT Slack, our GitHub discussions, and then Alena has been working on some awesome educational content. So definitely check out DLT Hub's education portal and our documentation, their documentation. And yeah, let us know if you have any questions. Speaking of questions, there are quite a few in the Q&A. Alex, do you want to go through some of those and we can try to answer them now?
Yeah, there was quite a few around like how do you handle back off time and retry accounts for REST APIs. So if I think that's like DLT specific. So if Luna and Aashish want to weigh in on that.
Yeah, DLT supports built-in retries and with the back off time. If you run DLT pipeline and you make it fail, you will notice that DLT will try to request 5 times your API, REST API. But it's not only for extraction, it's also for loading. When you're trying to load your data to destination, if connection is broken, DLT will retry it several times until it's on. If it's broken forever, so it will raise an exception.
Awesome.
Take DLT fundamentals course, you will learn everything.
Yeah, so we had another one from Andrew about how does parallel processing in Dagster work when we have DLT transformers that depend on earlier stages of extraction rather than independent resources.
Yeah, that's definitely the corner case where it gets tricky. The factory pattern that Ashish showed here, you would have to possibly add some logic there where you group the resources that are dependent on one another into the specific assets. Like the with resources would have to have the ones that are dependent on one another. By default, just using the DLT assets decorator, it doesn't operate concurrently. So as you saw in the first demo, those will all run sequentially. So I think right now that story requires a little bit of improvement and requires a little bit of hacky workarounds to manage that corner case.
Yeah, currently parent and child dependent resources should be run in the same process. Don't split them. But you can run transformers in parallel in multi-threading using DLT functional. We can show it to you maybe next time.
Awesome.
Join our community. We can discuss it more later.
Yeah, I think that's general advice for any of these modern data stack open source tools. We all have community Slacks with folks like ourselves here that are happy to answer questions and help you along the way. We have another question here from Tuan, which is how does DLT handle incremental loading?
Ooh, that's a good question. I know there are multiple ways if you want to go into it, Aashish or Alena.
Do you want to answer?
How it handles incremental loading?
Magically. Magically.
I mean, they're different approaches. So the default is, oh God, it's not upstart. Which one is it again?
Okay, you can use DLT incremental with defaults, for example, for append. I don't know, I can show you the documentation. It's just one line, how you can turn it on. So nothing difficult.
Yeah, when you define your pipeline, you can specify the write, was it write disposition?
Yeah, write disposition, but it works for any write dispositions except replace. If you want to erase your data on each iteration, of course you can use replace, but yeah, it works for append and merge. So you can
customize this. But that's one of the magic things where if you define the primary key, like the ID or a timestamp, it'll know to go and query the API only for records after that timestamp and then just append those to the table. So it automatically handles incremental loads. That's one of my favorite features of DLT, actually. I guess it's worth noting, though, that's a little bit different than using partitions in Dagster, for example. So DLT handles this state for you, and they maintain that timestamp of when it should collect records, which is different than Dagster handling the state for you. But yeah, it has replace as well. Cool. That's a good question.
We have another question here from Anonymous, which is it possible to replace 5tran with DLT?
Most definitely. And I believe we have. We still use 5tran internally for a few things, but for the most part, yeah, we've replaced a lot of our usage even with it.
Yeah, I think we saved like $40,000 annually when we made that switch.
Yeah, open source tools are great.
I would say, can Python script replace 5tran? So DLT is just a Python script with all the hidden complexity. If you can code.
Cool. Any more, Alex? We're up on time.
Yeah, we got 10 more, but I think we can handle them in the Dagster Deep Dives Slack channel in our server, and me and Colton and the DLT folks will be in there answering those questions and any others that come up. But we got a lot of great questions and engagement today, so I really want to thank the audience for their engagement and questions. They're fantastic.
Cool. Yeah, thank you all for joining. I hope you learned something new. And thanks so much, Aashish and Alena, from joining us from the DLT side. We'll see you in the Slack.
Yeah, thank you
Thank
guys
you.
for inviting.